Alright, students, Assalamu alaikum. So today we are doing IGCSE Chemistry Paper 2, which is MCQs, October, November 2024, Variant 1. Alright, let's look at the first question. Which row describes the arrangement and motion of particles in a liquid? So in a liquid, particles are close together, right? And they're still moving. So let's look at what we have. So in the option A, we have random arrangement, alright, and particles are touching. That is also true. And the motion is slow. All right, so everything seems correct about A, so the answer should definitely be option A. Okay, so the first question answer is option A. Next question we have, which gas is the lowest rate of diffusion at room temperature and pressure? The gas produced when ammonium chloride is heated with aqueous sodium hydroxide. Well, when ammonium chloride is heated with aqueous sodium hydroxide, it produces ammonia, NH3, right? And ammonia has a mass of 17. All right. Slowest rate of diffusion means the gas which is heaviest. Okay, so we are looking for the gas which is heaviest. The gas which makes up 78%. So that is nitrogen N2. And one nitrogen has a mass of 14. Two nitrogens have a mass of 28. All right, so this is N2 whose mass is 28. All right. The gas produced when sodium carbonate is added to hydrochloric acid, that is carbon dioxide. All right. And the mass of carbon dioxide, you should remember, is 44. Okay. How do I remember the mass of carbon dioxide is 44? Or how is the mass of nitrogen N2 28? Or how is the mass of NH3 17? All you have to do is just go to the periodic table and add their masses. So, for example, in the periodic table, the mass of nitrogen is 14 and each hydrogen is 1. So 3 hydrogens means 3. So 14 plus 3 is 17. And two nitrogens meaning 14 plus 14. That should be equal to 28. All right. CO2, one carbon has a mass of 12, oxygen has a mass of 16. Two oxygens would have a mass of 32. So 12 plus 32 would give us 44. Next, the gas produced when zinc is added to dilute sulfuric acid. When a metal is added to acid, it produces hydrogen gas, H2. Hydrogen has one mass, so there should be a total of two mass. So which is the heaviest gas? C is the heaviest gas. All right. Next question. Which diagram represents one helium atom? Now, a helium atom contains protons, neutrons, electrons, and helium atom contains two protons. It has atomic number 2. It contains two electrons, and its mass is 4, meaning it contains two neutrons. So 2, 2, 2. Now, electrons are always in the orbit, meaning they are on the outer side. They are orbiting, and protons and neutrons are in the center. So in which diagram do we see electrons in the orbit and protons, neutrons in the center? We see it in option B, right? Look, these are protons, these are neutrons, right? They're in the center and electron is on the orbit, all right? Next question, the diagram shows part of the ionic lattice structure. Which compound does the diagram represent? As we can see, it contains equal number of positive and negative ions, so it must have the same things. Like for example, K potassium bromide would be KBr, right? And this means it's in the ratio 1:1. We should say that A would probably be the right answer. Okay, but let's look at the others as well. Sodium oxide, that is Na2O. So that is not, because if Na2O, then there would be twice the number of positive ions than negative ions. Magnesium chloride is MgCl2. All right, MgCl2. MgCl2 would have twice the number of chloride ions, meaning twice the number of negative ions. Well, this contains equal number of negative and positive ions. Carbon monoxide is not even an ionic compound. Not an ionic compound, right? So the correct answer was A. All right, on to the next question. Question number 5. Which statement about nitrogen molecule and ethene molecules is correct? A nitrogen molecule has two more shared electrons than an ethene molecule. Well, for this sharing stuff, we'll have to show a nitrogen molecule. This is a nitrogen molecule, and an ethene molecule is this, right? Okay, so nitrogen has a total of 6 shared electrons, and an ethene molecule has a total of 1, 2, 3, 4, 5, 6, meaning 12 shared electrons, because it has 6 bonds, right? So it has 12 shared electrons. All right, so let's see, a nitrogen molecule has 2 more shared electrons. Then that is not true. An ethene molecule has 3 more shared electrons. No, it does not have 3 more shared electrons, it has 6 more shared electrons. So we can see that the correct answer is option D, right?
Yeah.
Next question. Sulfur is a simple molecule with a formula S8. Which row describes and explains the melting point of sulfur? All right. So which row describes the melting point of sulfur? Well, melting point of sulfur S8 is not high. S8 is a simple molecule, right? It is a simple molecule, so the melting point is not high. And why is the melting point not high? They're asking. So the answer is either C or D, meaning low. The forces of attraction between sulfur atoms are weak. The forces of attraction between sulfur molecules are weak. But the forces of attraction between sulfur molecules are weak. Okay, the molecular attraction is weak. The melting boiling point breaks down molecules, like molecules separate apart. All right, the atom of each sulfur might be held together in an S8 conformation very strongly, and it kind of looks like a crown conformation, we say, right? There are three S's on top and five S's on the bottom. Let me just show you how it is. Five S's on the bottom, all right, like this. Okay, and then this is the kind of bonding there is. All right, this is the kind of bonding there is. Okay, S8 molecules, they look like this. Okay, um
जी.
so that because of this the molecule itself is held within itself very strongly, but another acid molecule might not be held as strongly. So the answer is D. All right, that is a generic answer as well. Textbook answer. Question number 7. Which row identifies a property and an explanation of the property for both diamond and silicon 4 oxide? The property is that diamond and silicon oxide are both, definitely they are very hard. This is true. So let's look at the second part. Explanation of property. Diamond has a giant covalent structure and silicon has a giant ionic structure. Well, this statement is wrong. Okay, this statement was correct, however. High melting point, that is their property. Both have giant covalent structures with many strong bonds between the atoms. Well, everything sounds perfect in B option, so let's say good lubricant, that is wrong. Poor conductor, that is correct. Both contain only non-metal elements and are simple molecules, that is wrong. All right, so the correct answer was B because both ticks. All right, next question. Which statement about the structure of metals explains why metals are malleable? The electrons can move freely throughout the lattice. That explains why they are good conductors. The layer of metal ions can slide over each other. That is the reason why they are malleable. All right. Next question. What is the formula of iron 3 oxide? Fe3 Fe2O3. Definitely, right? Because iron 3 oxide is Fe plus 3 and oxide is minus 2. So 3 goes over here and 2 goes over here. The answer is Fe2O3. All right. I mean, you did not have to do this. Most of you would remember what Fe2O3 looks like. Okay. Next question. Calcium carbonate is heated. Calcium oxide and carbon dioxide gas are formed. The equation for the reaction is shown. CaCO3 gives CaO plus CO2. 225 kilograms of calcium carbonate is heated until there is no further change in mass. Okay, the yield of calcium oxide is 85 kilograms. What is the percentage yield? A very good question of percentage yield. We know percentage yield is obtained mass upon calculated mass multiply by 100. All right. Now they are saying the yield of calcium oxide was 85 kilograms. All right. The thing is, over here, you do not have to worry about the unit. You can call it grams. All right. You can call it grams. We know the obtained is 85. Okay. We just need to find out how much actually was supposed to be produced. Okay, so for that you should know a few things. Calcium carbonate, what's its molecular mass? Calcium is 40, carbon is 12, and three oxygens would be 48 because one oxygen is 16. So in total it has a mass of 100. All right, I remember it has a mass of 100, but you guys can calculate it. 40 plus 12 plus 48, that is 100. All right, so it has a total mass of 100. And what is the mass of calcium oxide? It's 56, right? Because one calcium is 40 and one oxygen is 6. 40 plus 16, 40 plus 6 is 56. So we say that 100 grams of calcium carbonate should have produced 56 grams of calcium oxide. Similarly, 100 kilograms of calcium carbonate should have produced 56 kilograms of calcium oxide. So if we say 225 kilograms, right? So let's make it unitary method. If 100 kilograms of calcium carbonate was used, we would have gotten 56 kilograms of calcium oxide. All right. So if 225 kilograms of calcium carbonate is used, so how much kilograms of calcium oxide would be produced? We just cross multiply. All right. We just cross multiply. We are finding calculated mass. All right. So X is equals to 225 times 56 divided by 100. All right. So times 225 divided by 100 equals to, it should have produced 126 kilograms of uh, calcium oxide. So this is what we call the calculated yield. All right. So the formula becomes 85 divided by 126 multiplied by 100. All right. So 85 divided by 126 multiplied by 100. The answer we are getting is 67.46 or 67.5%. 67.5%, which is option C. All right. Next question.
Sir,
G.
can you explain, like, can you wait? I get why you did um the ratio thing, but then
Yes.
again, how it's a bit confusing. Can you explain, Shiru sir?
Okay, I'll explain once more. Look, basically what happened is calcium carbonate. One second, let me just pause the video for it. All right, on to question number 11 then. The apparatus used for electrolysis is shown. DC power supply, electrodes, electrolyte. Which statement is correct? Um, Copper forms at the anode in some electrolysis reactions. Well, uh, I mean, it does, but if only copper is there. So this is something like a question mark kind of statement because it's incomplete. So let's go to the next one. Hydrogen forms at the cathode in some electrolysis reactions. That is true. Acha, oh sorry, A is wrong because copper does not form at the anode. Copper forms
It
at
forms at
the
the cathode.
cathode, yes. All right.
Yeah, I was also.
Hydrogen forms at the cathode, that is true. Oxygen forms at the cathode, that is wrong. All right. Sodium
Yeah.
forms at the anode, that is wrong. All right. So
Mm.
B is the only correct answer. All right. So this was a very vague question, but the thing they were basically judging us on was whether or not we know which ion goes where. Okay. Next question. Question number 12. Which statement about the electrolysis of aqueous copper to sulfate is correct? When copper electrodes are used, the solution turns from blue to colorless. That is wrong. When copper electrodes are used for electrolysis of copper to sulfate, the color of solution remains same because only the anode decomposes and migrates and gets deposited onto the cathode. So the overall concentration of the electrolyte remains same. Okay. Next question. When graphite electrodes are used, bubbles of gas are formed at the cathode. That is also wrong. At the cathode, copper is produced, which is a metal. Okay. When copper electrodes are used, the anode gets smaller. That is true. The anode decomposes and gets smaller. Question number 13 then. Question number 13 says, which statement describes an advantage of using a hydrogen oxygen fuel cell in a car compared to a gasoline engine? The hydrogen is difficult to store. That is actually a disadvantage. Hydrogen is highly flammable. That is also a disadvantage. The hydrogen used is made from hydrocarbons. That is also not really anything, which is a disadvantage. All right. The only chemical product is water. That is an advantage. All right. Why is that an advantage? Because using hydrogen oxygen fuel cell would help decrease the amount of greenhouse gas emissions. All right. There would be less global warming. Carbon dioxide would not be produced. Two reaction pathway diagrams are shown, which arrow represents the activation energy for the reaction which releases thermal energy. Activation energy for a reaction which releases thermal energy, meaning for an exothermic reaction. All right. So they are asking us two things: whether or not we know which of these is an exothermic reaction energy profile diagram and what is the activation energy. So this is obviously the exothermic energy profile diagram. This is the endothermic energy profile diagram. So the correct answer would either be from A or B. B is actually delta H. A is activation energy. All right. A is energy of activation. Next question. Which statement about the Haber process are correct? A high temperature is used because the reaction is slow at room temperature. Um, Well, yes, that is true. The reaction is extremely slow at room temperature. Why? Because of the nitrogen triple bond, right? The N triple bond N is very strongly held. The old bond needs to be broken so that new bonds can form, meaning ammonia can be produced. A high pressure is used because there are more moles of gaseous reactants than more moles of products. That is also true. So the first statement is true, the second statement is true, and we can only choose a maximum of two statements. So the answer must be A. Let's look why 3 and 4 are wrong. A nickel catalyst is not used. This is
Sir, you're stuck. I can't hear you. Okay.
all right. Next question. Which substance is a raw material used to manufacture sulfuric acid? So, what is the raw material used to manufacture sulfuric acid? Vanadium pentoxide, that is not a raw material, beta. All right. Remember, vanadium pentoxide is the catalyst. The raw material is what we start with. We start with sulfur. First, sulfur reacts with oxygen to form sulfur dioxide.
So you're
Then,
not sharing your screen.
oh, sorry. Okay, 1 second. Can you see the screen?
Yes.
All right. The question was which substance is a raw material used to manufacture sulfuric acid? First option was vanadium pentoxide. This is wrong. Why? Because vanadium pentoxide is the catalyst, not the raw material. Without vanadium pentoxide, we can even manufacture sulfuric acid. All right. But the actual thing that we need is actually sulfur. Sulfur is what we start with. We react sulfur with oxygen first, producing sulfur dioxide. Then that sulfur dioxide further reacts with oxygen to produce sulfur trioxide. All right. Next question, question number 17. Which colors are seen when litmus and methyl orange are added to separate samples of aqueous sodium hydroxide? So, when litmus is added to sodium hydroxide, litmus becomes blue. All right. When methyl orange is added to sodium hydroxide, in alkaline conditions, methyl orange becomes yellow. All right. So, the answer is B. All right. Next question. Information about solubility in water of four oxides is shown. Which oxide, when added to water, gives a solution with pH less than 7? Okay. So, name of oxide, nitrogen dioxide. Is it soluble in water? Yes. And it gives pH less than 7? Yes, it is an acidic oxide. All right. So, when it is added to water, it does produce an acidic solution. Okay. Next question, question number 19. Copper 2 sulfate is made
Sir,
when copper. G beta.
are we supposed to know like which oxides are soluble and which are not?
We are supposed to not know which oxides are soluble and which oxides are not soluble, but we are supposed to know that nitrogen dioxide is soluble and
Okay.
produces an acidic solution. And we also should know that silicon dioxide is also an acidic oxide, but it is insoluble, it does not dissolve. You see sand, you put it in water, does it dissolve? It never dissolves, right?
Yeah.
Okay, next question. Question number 19. Copper 2 sulfate is made when copper 2 carbonate reacts with dilute sulfuric acid. Sure. Pure copper 2 sulfate crystals are obtained. Which reagent is in excess and how are the crystals obtained? Beta, copper 2 sulfate is a soluble salt. Copper carbonate is insoluble. We know copper carbonate is insoluble. Therefore, this is method 1 of preparation of salts. It's called uh, this method is called method 1,
Excess method.
which is production of
Excess method.
producing a salt with excess insoluble reagent or reactant, right? So the insoluble reactant is the one which would be in excess, meaning A or B is the correct answer. How do we do it? We first, after we put excess of copper carbonate, we first filter the solution so that the excess copper carbonate is removed. Then we evaporate the solution to crystallizing point and then cool. That is true. So the answer is B for ball. Next question. Which statement about elements in group 1 or group 7 of the periodic table is correct? Bromine reacts with potassium chloride to produce chlorine. Okay, bromine, it reacts with potassium chloride and produces chlorine. Iodine is a monoatomic non-metal. Um, is first option correct? Let's see. Bromine reacts with potassium chloride. It does not. Bromine is less reactive than chlorine, therefore it would not be able to displace chloride. All right. Iodine is monoatomic non-metal. That is wrong. It is diatomic, I2. Right. Lithium has higher melting point than potassium. The melting point of alkali metals decreases down the group. So this statement is actually correct. All right. It is also mentioned in the notes. Sodium is more reactive with water than potassium. This is wrong. So basically, if you did not remember the physical property of group 1 or the physical trend of group 1, that melting boiling point decreases down the group, at least you would know that these three are wrong. So therefore, it should obviously be C. All right. Next question. Some information about an element of group 7 of the periodic table is shown. The melting point of element of group 7 is -7. Boiling point is 59. Meaning, meaning it is liquid. Meaning it is liquid at room temperature, right? Because room temperature is 25 degrees. It would be liquid. And which one is liquid? Bromine is liquid at room temperature, right? So we can say that halogen is liquid at room temperature. Halogen is liquid at room temperature. Next question. Manganese 4 oxide MnO2 is a black solid. All right, sure. The equation for reaction between manganese 4 oxide and dilute hydrochloric acid is shown. MnO2 plus 4HCl gives MnCl2 plus H2O plus Cl2. All right. The reaction produces a pale pink solution. Okay. Which properties of transition elements does this reaction show? They can act as catalysts. They form colored compounds. They have high melting point. They have variable oxidation numbers. All right. So for all these, for these guys, we have to look at first of all, transition metals have three characteristic properties. All right. Those are that they can act as catalysts. They can form colored compounds. They have variable oxidation numbers. Now, which of them is shown over here? Is they acting as catalyst shown? No, it is not. All right. Are they forming colored compound? Yes. Pale pink solution is being produced. All right. Do they have variable oxidation state? Let's look at the transition element. Initially, it has a +4 oxidation state because two oxides are -2. All right. Then when it forms MnCl2, it has a +2 oxidation state because two chlorides are -2. All right. Any problems?
No.
All right. On to the next question. Part of a steel ship is protected from rusting using a sacrificial metal.
Sir, you didn't.
Oh,
It's
sorry.
which one is it?
So
So they're
therefore
from
it
colored
is
compounds
2 and
and
4.
2 and 4.
Yeah,
Yeah.
2 and 4. So it is 2 and 4. D option. All right.
Okay.
Next question. Question number 23. Part of a steel ship is protected from rusting using sacrificial metal. Using a suitable. What is a suitable sacrificial metal? Well, it is not copper because it is less reactive than iron. Iron is the major component of steel. It is definitely zinc. This process is also called with a very special name, that is galvanization. I've forgotten the spelling. Galvanization, right? The sacrificial protection method. This method is called galvanization, right? Silver is also less reactive than iron, therefore it can't be used to protect steel. Potassium could be used as a method of sacrificial protection, but we all know that potassium, it quickly reacts and probably might even explode the bottom of the ship because the reaction is so exothermic, right? We've seen the reaction of potassium that happens, right? And then also, even if the reaction was not that exothermic that it damaged the ship, the potassium would react quite rapidly and it would continue to dissolve in water, and then the iron would be exposed. Zinc, on the other hand, would form zinc oxide and it would be an insoluble barrier, right? Next question. Which row gives a use for the named metal and two properties with which both explain this use? Okay, the sentence, I don't know. I read the sentence wrong, but let's look at the properties. Aluminum, is it used in aircraft construction? Yes. Is it having high density? No. Copper,
No.
is it used in electrical wiring? Yes. Good electrical conductivity? Yes. Is it ductile? Yes. The answer is B. But let's look at others. Aluminum, is it used in food containers? Yes. Is it resistant to corrosion? Yes. Is it not malleable? That is wrong. It is malleable. Copper, is it used in aircraft construction? Wrong. All right. So B was the correct answer. Next question. The apparatus used for extraction of aluminum by electrolysis is shown. All right. Which equation represents the reaction at the cathode? At the anode. So what is the reaction at the anode? At anode, oxide gets discharged. And how would oxide get discharged? By losing electrons, right? Because at anode, electrons are lost, right? So the answer is B. All right. Oxidation takes place at anode. Oxidation. All right. And this reaction, this reaction takes place at cathode. This reaction takes place at cathode. Had they asked us about cathode, we would have said D. All right. Next question. Which gas is both an element and present in clean, dry air? Which gas is an element? It's, well, the only element that you can see is argon. Carbon dioxide is a compound. Chlorine is a molecule. Water vapors are compounds, molecules, whatever you can call them. Okay? And argon is also present in air. Next question 27. Oxides of nitrogen formed in cars engine are removed using catalytic converter. What happens to the oxide of nitrogen in catalytic converter? They are hydrated, they are neutralized, they are oxidized, they are reduced. Well, oxides of nitrogen, NO2, or basically NO, because it is simpler, when it reacts with carbon monoxide in the catalytic converter, it produces N2 plus CO2. All right, to balance the equation, we put a 2 over here and we put a 2 over here. All right, and we put a 2 over here. Okay, you can clearly see that oxygen has been removed. So this is called reduction, right? This is called
Reduction.
reduction. So they are reduced. Next question. What is the equation for photosynthesis? In photosynthesis, carbon dioxide and water join to form glucose and oxygen. So where is carbon dioxide and water joining to form glucose and oxygen? In option A, right? Carbon dioxide and water joining to form glucose and oxygen. Next question. Four statements about members of same homologous series are listed. They have same volatility, they have same molecular formula, they have same functional group, they have same general formula. Which statements are correct? Well, the basically um what is similar of all members of a homologous series is what they're asking. The
3
same
and 4.
functional group and the same general formula. That is what is correct, right? So 3 and 4 is the correct answer, which is D. Next question. Ethene reacts. Acha, by the way, they have same volatility. No, volatility actually decreases as size increases, and molecular formula also changes because of different molecules. Okay. Next question. Ethene reacts with steam to produce ethanol. Which row describes each compound? When ethene reacts with steam, it produces ethanol. Is ethene unsaturated? Yes, it is. It contains a carbon-carbon double bond. Is ethanol unsaturated? No, it is not. It does not contain a carbon-carbon double bond. So the answer is C. All right. Ethene contains a carbon-carbon double bond, but ethanol does not. Ethene contains carbon-carbon double bond, but ethanol does not. Next question, beta. Question number 31. Which process is used to make an alkene from long chain alkanes? It's called cracking. All right. Alkenes are made from alkanes by cracking. Next question. Which fraction obtained from petroleum has the lowest boiling point? Lowest boiling point means the one which is obtained at the at the upper fractions. All right. Naphtha, fuel oil, and diesel, they have pretty high melting points, right? Kerosene also has pretty high melting point. Ooh, so you have to remember in them which one has the lowest boiling point. Lowest boiling point would be the one that is collected above all others. Okay? So if you remember the fractionating column that we had drawn, right? If you remember the fractionating column that we had drawn, kind of looked like this, right? Forgotten to draw the entrance, all right? And it is coming from what we call a furnace, right? In the lower part, we have bitumen being coming out, okay? And then the next thing we have is diesel. Then after diesel, we have ship oil or fuel oil. This is basically ship oil or fuel oil, right? And now the confusion is between kerosene and naphtha. But a naphtha has a relatively low molecular size. It is used to make chemical products, right? It is a petrochemical. These guys are smaller in size. Naphtha is the one that will be collected above, and this would be kerosene. So the answer would be naphtha. All right. Next question. Alkanes undergo substitution reaction with chlorine in the presence of ultraviolet light. Which equation shows a reaction of this type? All right. So the reaction they're talking about is called the substitution reaction. And which reaction is shown in substitution reaction? For first off, we have to look at which of them is alkane and which of them is alkene. So this is an alkene, not an alkane. All right. So that is why this is wrong. And this is an alkane, that is right, but H2 is not produced. HCl is produced. Only one chlorine gets substituted, right? So the answer is either C or D. Well, this is also an alkene, so this is also wrong. The answer only could be C3H8. When it reacts with Cl2, one hydrogen gets substituted for one chlorine. Instead of 8 hydrogens, now there are 7 hydrogens in one chlorine, and one other chlorine joins with the hydrogen that has just been substituted. All right. Question number 34. Information about two reactions of ethene is listed. Reaction 1 requires nickel catalyst. Reaction 2 requires an acid catalyst. Which substance reacts with ethene in each reaction? All right. When we have a nickel catalyst, who are we reacting it with? Nickel is used for reaction with hydrogen. Bromine does not even require a catalyst. All right. So it's either C or D. And acid catalyst, where is acid catalyst observed? Right. Where do we usually see acid catalyst? In
Steam.
in steam we use phosphoric acid. In steam we use H3PO4, phosphoric acid, all right? And in hydrogen we use nickel, NiS catalyst, all right? So the answer is D for doctor. Next question. Which process converts CH3CH2OH to CH3COOH? Meaning alcohol to carboxylic acid. It is called oxidation. All right, it is called oxidation, and none of them say oxidation except for option A, bacterial oxidation, or non-bacterial oxidation, like using potassium dichromate or KMNO4 potassium magnate. We can also use, they are also methods of oxidation. All right. Next question, which is question number 36. The structure of an ester is shown. Which row identifies the name of ester and two compounds which it is made from? So to identify the ester, what do we say? We break the carbon oxygen single bond. The side with the carbon oxygen double bond is the carboxylic acid. It is the carboxylic acid. All right. And the side with the oxygen single bond with carbon is the alcohol side. All right. Okay. The name of an ester is always given like this. Name of an ester is always given in the form of alkyl,
So this is going to be ethyl propanoate.
alkanoate. Very good. And the alkyl part comes from alcohol, and the alkanoate part comes from carboxylic acid. Right? In this question, carboxylic acid is your 3 carbon long, which is meaning it is propanoic acid. All right. And alcohol is 2 carbon long, meaning ethanol. So the name is going to be ethyl propanoate. Compound 1 is going to be, well, compound 1 can be called ethanol because compound 1 is what they're calling alcohol. Compound 2 is propanoic acid. So the answer is A. All right. Question number 37 then. 37 says, which statement about monomers or polymers are correct? Monomers are always joined together by addition reactions. Is it true? No, not really. But let's see. A polymer can be formed from a single type of monomer. That is a true thing. We can have a single type of monomer to form polymers, and both condensation and addition polymers can be like that. Like polyethylene is a polymer that is made from ethene only, and proteins are a polymer made from amino acid only. Okay, a polymer can be formed by joining two different types of monomer. That is also true. So the third option is also true. Water is always produced when monomer molecules join together. That is not true. In addition reaction, water molecules is not produced, and addition reaction is not always the way polymers are made. So 2 and 3 are not 100% correct. However, the statements are correct, but always is not the right word. All right. So answer is C. Question number 38 then. The diagram shows the structure of a naturally occurring polymer Q. All right, we can see the polymer Q. What is Q? Is Q an amino acid, a nylon, a protein, a PET? All right, it's a naturally occurring polymer. So it can't be an amino acid. Amino acid is what? Amino acid is a monomer, so it can't be amino acid. It could be nylon, nylon is a polymer. It could be protein, protein is a polymer. It could be PET, PET is a polymer. Now the next thing, PET does not contain nitrogens. As you can see, PET does not contain nitrogens. All right, so this can't be PET. Now it could either be nylon or protein. To consider which one it is, we have to break down a repeating unit. This is our repeating unit. The repeating unit, as you can see, contains amino group, the NH group on one side and carboxylic group on the other side. That is the resemblance of a protein. Therefore, it is a protein. Nylon does not contain an amino group and carboxylic group on the same monomer. It contains two different types of monomers. They are called diamines and dicarboxylic acids. All right, so this is not nylon. Question number 39. Which row shows how the boiling point and the melting point of water change when a soluble impurity is added to the water? All right. So when soluble impurity is added, the melting boiling point, its range in the middle just increases. In the colder regions like in Europe and in the United States and those places, people add salt on their driveway during winters. That causes the frozen ice to thaw down. It causes it to melt because the melting point, it drops down, right? So the melting point, it actually decreases, all right, and the boiling point actually goes above 100 as well. So the answer would become C for cat. All right. Question number 40 then. X is a white powder. The following tests are done on X. When a few drops of aqueous sodium hydroxide are added to a solution of X, no precipitate are seen. So when aqueous sodium hydroxide is added, no precipitates are seen. All right, meaning it does not give a positive test for sodium hydroxide. So it can't be in the cations that we remember in our list, right? It can't be aluminum, can't be calcium, it can't be uh, any other one, right? Next question. When X is heated with aqueous sodium hydroxide, no gas is formed, meaning it does not contain ammonium as well. Ammonium ion is also not present. X gives a lilac khatam. It has purple, something purple, all right? So, matlab, it has
Potassium.
potassium, all right? The answer is C or D. Okay, now let's look. When acidified aqueous silver nitrate is added to solution X, a yellow precipitate is formed. This is confirmation of iodide ion, and this is confirmation of potassium ion. So potassium iodide should be the answer, which is option D. And with that, our answer
So you're
is
lagged
complete, and
again.
we have